Hello.
Great. Hi, James. So very nice to see you. So James is joining us from Swansea.
Yes. Yeah.
Very nice. Swansea is a beautiful town, and a center of competence for printed electronics and printing in general. And he'll be telling us about magnetic separation of silver conductive materials for fully biodegradable electronics. And James, I'm not quite sure how to pronounce the name of the company. Maybe you can tell me.
Yeah.
AilArian?
So AilArian. So it's actually a translation from Welsh for
Okay.
re-silver or recycled silver. So
Oh, I
it's
see. So it's a
or
Welsh
not
name.
to where we come from. So
Nice.
I thought I'd add that. Let's share my screen. Okay. Thank you. My name's Dr. James Claypole. I'm the founder behind AilArian. As we just mentioned, AilArian is the translation from Welsh for re-silver. So it's a little nod to where we started and where we came from. So something we've often not talked about so much is the reason behind us going down this route. So I worked as a printed electronics researcher for about 10 years, and we were working on a wearable technology project which had some printed electronics going into garments that were used by Olympic athletes. And this was just around the time of COVID. And we had a lot of time to wait between, because a lot of our projects got delayed. So we actually got to thinking about what was happening to all of this printed electronics that we were making at prototype stage, and where that was all going. And what we realized was quite a large proportion of the materials and things that we were making, all of these prototypes that were failed, all of the waste material we were creating, even on a relatively small research scale, was all literally going to, if we were lucky, it was going to incineration, and if not, it was just going and disposed of as hazardous waste along with a large number of other things. So that was part of the reason we started this project, this company, was to look for an alternative. Advance my slides. Here you go. So the problem, you've probably heard these numbers quite a few times by now, is the 60 million tons of electronic waste that were generated last year. This number is increasing, making electronic waste one of the fastest growing waste streams in the world. And it's quite a big issue in the EU with 16.2 kilograms per person. Of that, globally, less than 20% of the electronics that we make are actually recycled in any form. But let's have a little think about what that means to be recycled, because it can actually take quite a lot of different routes. So generally, electronic waste is recycled in one of two not particularly friendly ways. So you have pyrometeorology, which basically involves, the closest way to describe it is smelting, and you incinerate everything, and then you float out the liquid precious metal from the scrap electronic waste. The other one is hydrometeorology, which uses an array of some particularly unfriendly chemicals. I think the industry standard name for the solution they dissolve the electronic waste in the first place is piranha solution, because it literally creates a soup of other material out of the electronic waste that goes into it. And then they use some more not particularly friendly chemicals to actually precipitate out the precious metals before processing them. So if you could, to break this, to make this a little bit more relevant, so the chemical that they were so worried about being on that container ship that collided in the North Sea was actually one of those chemicals that they use in this process. So that was what they were so worried about entering into the water system. So again, so this is what the focus of the recycling process is. The whole focus of the recycling process is the extraction of precious metals. And it is at the expense of everything else. So the substrate, the semiconductors, the smaller trace elements of metals, sometimes which are your critical raw materials, just become a big pile of other material or slag or fly ash or from whatever process, variously just dumped because it no longer has a use. So what about printed electronics? So how do you